After creating, saving, and closing both pieces, it is now time to assemble them to one assembly. So I'm going to click New, and this time I'm going to pick an assembly feature. It's very important that you actually choose the assembly because you're not creating an individual part, and a drawing is not what you need. If you do not create an assembly, you will not have the tools that you need. Go ahead and push OK. And what it'll ask you to do is to bring in your first part. Now, a lot of people will just click whichever one. Now, the first part you bring in will be locked in space. So if this was a toy car and the wheels needed to rotate, I would not want to bring the wheel in first. I would want to bring the frame or the body in first. In our case, we're going to bring in the board first because it's our largest part. It's going to be set in space, and we're going to move everything else around that. So I'm going to go ahead and select the board and click Open. It will then be attached to my cursor, and at this point, just clicking to set it down will do exactly what we need it to do. The nice part is this board is linked back to the board that we created earlier. It's not like we just copy and pasted it in. So if I go back and I made a change on the original, this file would update, which is really, really nice when you're making adjustments, especially looking for things to fit. So in order to bring more stuff in, I have to go to the Assembly menu, and I have to go Insert Component. I'm going to see the exact same thing I saw before, and I'm going to pick Bolt. For now, I'm just going to set it down out here, because in SolidWorks world, I'm not just going to move this and kind of fudge it a little bit, because as you can see, as I move things, they essentially will just run into each other and go over top of each other. It's also not the most effective way to line things up. What we're going to use are these things called mates. These might be a little confusing at first, but as you get the hang of it, you'll notice which mate helps you do the job you want to do. And a lot of that comes from thinking about how would we actually put these things together. Thinking about that, I would probably line the stem of the bolt up with the hole in the board and then push them together. So that's exactly what I'm going to do digitally. To align two cylinder surfaces, I can go to Mate, and the one I'm going to pick is concentric. Now, this is a smart tool. So if I click on something circular and something circular, it's going to pick that one for me. Okay? I could have also chosen the mate and then clicked on the two surfaces. Sometimes that's easier when you're not sure what you're doing. Let me just cancel that for a moment here, and I'll show you what I mean. For example, if I picked a concentric mate, and then I picked this circular surface, and I tried to pick this edge, it shouldn't let me pick that. You can notice it won't, and it's not valid for the mate type. So if you know you need a certain mate, but you're not quite sure what you're doing, it may be helpful to select the mate first. I can now pick any sort of circle, and again, concentric, when we break it down, con meaning with, centric, center. Okay, so it lines everything up in the center. Now, does that mean that the centers are attached? No, it just means that the center line through the bolt and the center line through the hole in the board are now the same line, and we cannot break that rule. The next thing I said I would do is I would probably push, after I line it up, I would probably push the bolt into the hole. Now again, this is not something I can do manually because it's as though my bolt is a ghost. It will just go right through. So what I'm going to do is I'm going to click this surface, because really what I want is I want that surface touching this surface. And it moves into place and gives me a coincident mate. Coincident is one of those that's a little bit tough to get your head wrapped around. Basically, I picked two surfaces, so those surfaces will always be on the same plane. They will always be lined up, even if they're not touching, like these two are. But if there was one that, if I made them, let's see, I can accept that. By the way, just so you're aware, mates gets its own thing right here, and if you ever need to, you can come down here and delete them and remove that rule or that mate. Do not just continue. If you make a mistake, if it doesn't do what you think it should, don't just keep adding mates. Okay? Remove what you didn't do correctly and put it back in. Back to consent or coincident. You'll notice that even if I move it out over here, those two surfaces are still lined up, and I can't move that. Even though it looks like I was moving it vertically, you'll notice I was just moving it horizontally. There's no way for me to break that rule now. Those are going to be forever lined up while that rule is in place. So I'm going to go back to mates. I'm going to put my concentric mate back in there, and everything's good. Now at this point, one would probably believe, hey, this should be fully defined, but currently it's underdefined. The reason behind that is I can still spin this bolt. Now, if we had put threads on it and threaded the bolt into the board, at some point it would have stopped. And we're going to pretend, just to make this look really nice and neat and clean, that it's going to stop when one of these surfaces is flat. Now, to do that with a mate, I have to either have something it can line up with, like this top edge. Okay, so I want this surface right here to be mated somehow with this top edge, but I don't want it to pull the bolt out of here. That'll break my other rules. Here's what I mean. If I pick mate, you'll notice first off that I had that face selected, and then I went into mate and it put it right in the list. That's handy to know. And then I picked these two surfaces. Okay. In the old days, it would want to try to make them coincident, and it would give you an error. They've improved the software to realize, hey, I can't do that, but you know what I can do is a parallel mate. So I'm now making those two sides parallel. Okay. We'll often use this too for stuff like distance mates or angle mates. Okay. If there's any mate that lines up backwards, okay, now all my mates lined up just fine, but if you ever need to try to switch the alignment, there's these two buttons here that when you click it, changes the alignment. You'll notice that it put the parallel surface on the other side of the bolt. So if you need that, that's there. I'm going to go ahead and accept this. At this point, I should be, and I am, fully defined. If you get to this point before your teacher has told you it's time to start making drawings, please go back and make a part that would be a nut on the back side of this bolt. Hex head the same size, with a 1-inch hole instead of a 1-inch stem, that you would be able to put on the back side of this. And then try assembling that on your own. At this point, I'm going to save this in my same folder. Now here's something to be aware of. I won't see my other parts because they're the type part. Okay? This is an assembly, so don't freak out that you're in the wrong folder. Verify you're in the correct folder, but also verify that but also don't be thrown off that those files don't appear. Okay? This is going to be board dash bolt slash here, so board dash bolt. Okay, and it's an assembly type, so I'm going to hit save.